Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and today's video is going to be a little bit of a continuation from last week. If you recall, in the last video I took a piece of metal similar to this and used a surface grinder and put a cutting edge on one side. Found the angle, ground it down, flipped it over, ground it down, like I say, to make a cutting edge. I'm not really sure, can't really remember if I mentioned what I was going to use that for or what I was going to use it in, but I'm going to do a reverse build today. The product is finished. What it is a guillotine. Now, stick with me. This is not for chopping baby doll heads off or chicken heads off or any kind of animal. I've got a legit use for this, and watch real close because this is a real short video, but I'm going to show you what it's for, what this will be used for. If you've been following the channel very long, you may recall about a year ago this time I built a machine to actually cut corn off the cob. That saved a great deal of time this spring, late spring, early summer, when the wife and I put up some fresh corn in the freezer. But one of the tasks that was still kind of tough on older hands was cutting the ends of the cobs off. And I had all this material. The only thing I had to buy for this was this $17 air valve right here. So I decided I'd put this together, and I wanted to go ahead and get it finished to be sure it was going to work before I even showed it to you. But the first thing we're going to look at on this is this coupling nut right here that couples the ram on the cylinder. This is 1.5 inch cylinder with a 3-inch stroke. We're going to look at this coupling nut. Of all the parts of this, there was probably more machining involved and more procedures involved in this simple coupling nut right here than all the rest of it put together. To make the coupling nut, I'm going to be using this piece of 3/4 inch hex stock. The piston itself is threaded for 1/2 20. So we're going to drill and tap this for the 1/2 20. Don't know if my tap will reach all the way through. Almost. But what we're going to do is drill it all the way. Then we're going to thread what we can thread and part off about 1/4 inch of this to use as a jam nut. Okay, that last little bit wanted to be kind of hard to break the tap through, but we got it through. And that's going to work just fine. Alright, now we need to turn over to the mill and actually get this coupling nut attached to the blade. I've got our coupling nut in the mill vise now and got a 5/32 end mill in. The thickness of the blade is 160 thousandths, so 5/32 is 156. So that's going to be just a little bit small. But what we'll do is mill this down as deep as the end mill will go, test fit it, and then maybe move over a couple thousandths on each side to make up for that 4 thousandths. So I'm going to take this extremely cautious through here, simply because I don't want to break this. Okay, we're down to depth now of all this end mill will do. And this should be just a little bit shy of the blade going in. Nope, that fits perfect. There's just that much wobble in my setup, I guess, or that much movement in the table. So now I want to drill and tap for 1020 through both of these pieces. I'm going to get that set up and I'll bring you right back. Okay, I've got the blade set up in the mill now and got the coupling nut centered on the blade, which the blade is centered, or the spindle is centered over the blade. I'm going to center drill this, then I'm going to drill through this top layer and the blade with the clearance bit for 1024. Then I'll take this out and put the tap drill for 1024 in, drill the other side of this and tap it. Okay, I was able to hold that steady enough to get the hole through this side and this piece. But what I'm going to do now is take the blade out, mount this in, and get centered over this hole that I drilled, replace the bit, and drill and tap for the 1024. Okay, I'm centered back up over my hole now. So I'll remove the clearance drill. And this is the tap drill for 1024. Alright, I'm going to deburr everything and we'll put the pieces together. Okay, let's start by mounting the coupling nut to the to the blade. We'll take our 1024 socket head cap screw and tighten that down. Now the final installation or put together of this, of course, will have plenty of thread lock on it. Now we'll take the jam nut that we cut off, run it up on the cylinder. And of course the whole ram in the cylinder will turn. But on the final installation, the jam nut will be tightened up in there. And as this pushes down, it's not putting but a very minimal amount of pressure on this 1024 screw. Where the pressure is being applied is on this shoulders of the coupling nut, and the ram is run down to where it's touching the blade as well. So there's how the blade is attached to the ram. The next part we're going to look at fabricating are the uprights, the two uprights. To make the uprights, I started with this piece of square stock I had in my material pile. I think this probably started out as 1 1/8", 1.125. After cleaning it up, or I cut a couple pieces about 7.5 inches long, and after cleaning it up on a surface grinder, I'm at 1.11, and I was particular on the surface grinder to grind both directions to the same height. That way I didn't have to worry about the orientation. What we're going to do for these uprights, first thing we're going to do is mill a groove through the center of that. We'll go 7/32 wide, which give just a little bit of play in the blade. We'll go 150 thousandths deep, and all that is a track to keep the blade from twisting in our device. Once we get that done to both pieces, we're going to stand this up on the end and drill and tap for a 5/16 thread. We'll do that on both ends of both uprights. I've already got the center located and got the Z-axis located. And again, just like before, we're going to take this real slow and simple, or take it depth-wise real slow, just so we hopefully don't break the Alright, I think before I go any deeper, I went about 20 thousandths on that first cut. And checking that width, that's a little bit more play in there than I'd like. So I'm going to step down to a one size smaller end mill, which would be a 3/16, and try that. Okay, I've got the 3/16 end mill in now, and I got the depth set, so we'll continue on. Okay, we got about 10 more thousandths to go But again, what this groove is for is a track for the blade to travel up and down. So we'll take this last 10 thousandths out of this piece. All right, that's got our groove cut in one of the uprights, or our travel slot track. I'm going to take this piece out, do the same thing to this one, deburr on both, and then I'll bring you back when we get ready to drill and tap. I think I might have said 3/16, but we're going to use 5/16 to attach the top and the bottom. Okay, I've got the track cut in both of the uprights, and what I've done now is set it in the mill vise. I've got a work stop here so I can repeat, but I've located the center in both directions, and using a machinist square here, I'm being sure it's plumb. I'm going to drill and tap these for 5/16 18. Okay, and here's the two uprights finished now. Next we'll look at machining the top and the bottom. For the top, I'm using a piece of 1/2 inch thick, 2 inch wide by 7.5 inch long flat bar. What I'll do for the top, there's going to be a 1.3 inch circle that or hole cut out here that the ram will fit down into. On each side of that, I'm going to cut a slot. That slot will not be very deep at all, about 0.7 inches deep. But it's for the uprights to fit into, basically to keep them from twisting any. Just be, again, just a small slot. What I'm going to do to begin with, though, is take this, I've already located center on X and Y axis, got DRO zeroed out. I'm going to take this old broken end mill that I put a point on and just simply scribe some witness marks on here. That first inside cut for the uprights is at 1.97 inches. And the second mark is 3.08. All right, I'm going to do the same thing to the other end. All right, I'm going to get the end mill in now and start milling out these two slots. All right, that fits in now. I'm going to do the same thing to the other end of this piece, and I'll bring you back when we get ready to do the center hole. Okay, I've got the slot cut in both sides, and again the purpose of that slot is to keep the upright from twisting. I'll do the same thing in the bottom when we start it. But before I put the bit in to drill this hole in the center, I've got this sharpened end mill in again, and I'm going to scribe a line right down the center. And you'll see where that's going to come into play a little bit later in this video. Alright, again, you'll see where that comes into play shortly. I'm going to put the cutter in to start this center hole. Alright, the hole in the center needs to be 1.03. I might have said 1.3 before, but it's 1.03. I've got a 1-inch annular cutter. I'm going to use that to start the hole, and then we'll use the boring bar. Alrighty, I'll get the boring head in now and bring that out to 1.3. Okay, I made a cleanup pass on there, and I don't have but just a little bit left to go. Slug from the annular cutter was under there. Now let's see if we got enough room. Couldn't have been any better if I'd measured it. Okay, now I may come back. Remember, this is going in from this side. Depending on how much threads I have left through there, I may come back and put a little relief on this side as well for the nut, and might even put the nut in the lathe and thin it down some. That's a full 1/2-inch nut. I'd love to get at least maybe 3 or 4 threads on there. Alright, I'm going to deburr this piece now, and then we're going to go over to the workbench, and I'll show you what these little slots right here were for. Okay, if you recall, a few minutes ago when we made the uprights, I drilled and tapped holes in each end, and what I want to do is transfer this hole to that center line that I scribed in both ends here. Could measure that, but I feel better just transferring this one mark. Now I'm using these transfer punches. This is a 5/16, 5/16 18. First time I've used them on anything probably less than 3/8. So I was a little bit disappointed in this handle right here. The walls on it, the walls on it are kind of thick, but I'll run it down what I can with this, and then take one of the ignition wrenches and run it down all I can. So now we've got a little bit of that point sticking out. And what I'll be able to do as I pull this through there, I can feel when that point hits in that line we scribed. Right there. So I'll just take my hammer and transfer that mark. Now I'm going to do that to both sides, go over to the drill press and drill them out, and I'll meet you back for the assembly. Alright, I think I'm finished with the top and the bottom now. What I did with the bottom, I decided not to mill in the slot like I did up here. This will, again, the only purpose of that slot was to keep these uprights from twisting, and being recessed into here, they're not going to twist. In the bottom, what I did was cut a slot all the way through that the blade can go in. Should I have to rethink this and make an angled blade, it will need to be able to pass through this bottom. I also drilled for the holes to attach to the uprights and countersunk those. Everything's coming together real good with no air pressure on it. Just gravity should bring it down. And it does, so there's nothing binding. If I put my finger over the hole up here, that should create a vacuum and not let it go down. Air pressure will push it down. Then the air would be reversed here and it will go up. Of course, it's not going to slide down slow like that. It's going to go with a vengeance. And finally, we'll talk about plumbing the air supply. I did not video the plumbing of the air to the ram up here, but all I did was drill and tap 3 holes down here to mount the control valve, and then plumbed accordingly. Now I've got an entire video dedicated to simply to how these valves work and plumbing. I'll try to remember to put a link to that in the description. As you can see, it comes down with a pretty much of a vengeance now. I'm going to take the whole thing down, clean up all the dicam off of it, clean up any clear coat that I've sprayed on to keep it from rusting while I was building this project. Give it a good paint job, and then we'll come back and see if it works. Okay, I went down to the local fresh produce stand yesterday, picked up 4 ears of corn. Any of you that may not be familiar with how corn comes out of the field, this is sweet corn. It's considerably smaller than the corn raised as grain for livestock or milling for flour, so forth, corn flour, cornmeal. But this is the way it comes out. This normally comes breaks off when it's pulled off the stalk. Sometimes part of this stem will break off a little shorter. But what we want to do is cut this just where that stem goes in, and then cut this other end off. As I say, I picked up 4 ears of corn yesterday. Used 2 of them doing a little bit of experiment. I couldn't stand it without trying it ahead of time before I took it down and painted it. Now, what I expected to happen, or the scenarios of what could possibly happen when I hit the lever on this, was number 1, best case scenario, it chops it completely off. Clean cut and finished and done. Second possible scenario is it stalls it. It won't cut it at all. You know, I'm not sure just how much force is on this ram. 1.5 inch again, cylinder. I'm using 100 psi of line pressure on this. I've got 150 psi tank pressure if I needed it. But I'm going with what I usually run my shop air at. So the first case, or best case scenario, clean cut. Worst case scenario, it stops and doesn't cut at all. Possibly something in between as well, where it cuts about halfway through before it stalls the ram, and I have to release it, maybe turn it over and cut again, which would not be catastrophic. It wouldn't be bad at all. This is pretty tough, and again, old hands. Not easy using a butcher knife cutting that off sometimes. So again, I had all these parts. I decided I'd try building it. Let's see what it does. All right, we got a clean cut. And I didn't necessarily plan it, but you actually want, it's actually nice to have a little bit of this shuck left in here that you can use to pull the other shucks off. And again, if you're not familiar with fresh vegetables, these are called the silts. There's one of these silts for every grain of corn on the ear. As I said earlier, back about a year ago, I built a device to cut the kernels off the cob. I'll put a link to that in the description as well if you haven't seen that video. But what it basically does is uses an air ram to push this ear corn through a cutter that I made that cuts the kernels off the cob. Hope you enjoyed this little video. I realize not many of you will ever have a desire or need to build a guillotine like this to chop corn with. Hopefully you won't build one for any sinister reason. But I hope you enjoyed the sharing of the concept and the machining and fabricating of each part. Now I'm going to chop these two ears up into just small little segments. My niece and nephew who lives up the road from me have got some chickens, and I'm going to carry this up there and let the chickens have this. We've got plenty of corn in the freezer. Take care. I'll see you in the next video.